Okay, welcome back. We have this little integral here that we have came up with. Today we're talking about U-substitution, our final video on Calc 1. So, what is U-substitution? Well, U-substitution tells us that if we have the integral of f of x times f prime of x dx, we can evaluate that using this simple trick. So what we can see here is we have x squared and 2x, which is the prime of x squared. So what we're going to do is our original function, we're going to let that equal u. So we're going to let x squared equal u. Now we need to find what dx is, and we need to find what 2x is. So what we have is if we differentiate both sides, we have du over dx equals 2x. Cross multiply, du equals 2x dx. Perfect, we have that. So this is just the integral of u du. What's that? 1 over 2 u squared plus c. Let's substitute for u. Our u is x squared. X squared squared is x to the 4 plus c. Let's double check. What if we just multiplied these together? Well, we would get the integral of two integrals of x cubed dx. You can always take this constant out. We know that from our sum notation. We know that from derivatives. This is just an antiderivative. Let's do this. We get 2 times 1 over 4 x to the 4 according to the power rule plus c. 2 divided by 4 is 1/2 x4 plus c. Same thing. Boom. Let's do a bit more complicated of one. Let's do this one. Integral of sine x cos x dx. What's this? Let u equal sine x. Or actually, you know what? We'll make this a little more fun. We'll go from 0 to pi. So, how would we integrate this? Because now we have a definite integral. We want to find the area under this curve. Let's find it. So we'll let u equal sine x. Du, of course, equals cos x dx. But x equals 0. So then u equals sine of 0. That means u equals 0 down here. X equals pi. U equals sine of pi, which is also 0, which means we have the integral from 0 to 0 of u du. If we have an integral from just one point to the same point, there's going to be no area there, so this is just 0. Very easy. Make sure to change the bounds of integration when you're doing U-substitution. But yeah, that's very exciting stuff. We're finally done with Calc 1. In Calc 2, we're going to talk lots about some, let me show you. We're going to talk about things like this, using multiple variables. We're going to talk about volumes and stuff. We're going to talk about arc length, so the length of a curve, surface area, more trig integrals like this, but much more complicated. This is actually a very fundamental integral for Calc 2. We're going to talk about many other integration things. We're even going to talk about integrals that go all the way to infinity. We will see how limits come and haunt us once again. And then we're going to get into very fun stuff with sequences and series, like we just talked about our sums earlier. lots of stuff like that. And finally, approximating different functions in terms of a polynomial. So I hope to see you guys in Calc 2. I hope your exams go very well for Calc 1, or I hope this entire series has helped you very well with Calc 1. I appreciate every single view that you guys have given me. You've done very well along the way so far. It's only been a few days. So thank you very much. Give yourself a pat on the back. We're done with Calc 1. Yeah, thank you so much.